Hello ladies and gentlemen, and thank you for listening to Mr. Laxton's video on these 7.2a Algebra 2 notes. Alright, today we're looking at properties of rational exponents, and this grid right here you've seen before, and we've talked about before, this grid of properties of exponents. Alright, we've looked at these, we've talked about these before, but now we're really just doing it with these rational exponents, these fraction exponents. Alright, awesome. So here my essential question is today is how do I use the properties of exponents to simplify expressions. All right, how do I use these properties to actually simplify these guys? All right, so this grid here, I just copied it down for you again. This, you've seen it before, we've talked about it before, all these power of a product. If you're taking these, multiplying them, then you add those exponents. All right, if you have a power to a power, or power of a product, you can actually take these guys, put them together. You can just distribute that m onto both those guys. Power of a power, that's the one where we take n onto m. If it's raised to a power, then you multiply those exponents. All right, and negative exponents, we kind of talked about that in the last lesson, is that if it's negative on top, it moves to the bottom. If it's negative in the bottom, it moves to the top. Here's going to be a key one today as well, quotient of powers. If you're taking these guys and you're dividing them, then you take the exponents and you subtract them. All right, so these things are also good here. The product property of radicals, you can break these radicals up into two radicals. You can take two radicals and put them together if they have this same index out here. And then the quotient property, if you have a quotient underneath a radical, you could break that up into a quotient or a radical on top and a radical on the bottom. All right, so we're just going to kind of jump into these examples here and talk about, hey, what they are, what they look like, and how they work. So here, notice for number one, my 2 is my base, all right? And I have these different exponents. I have 2/3 and I have 1/6, all right? So if I combine these guys together, I'm going to take these exponents and I'm going to add them, all right? That is the power, product of powers one up here, this very first one up here, all right? So if I look at these, now I have 2 to the 2/3 plus 1/6. All right, and this goes back to our good fraction mathematics here, is that we have to make sure we have common denominators if we add. So the least common denominator between 3 and 6 is 6. So I want to make these common denominators of 6, and this one already has 6, so that's nice. I have 1/6. All right, so 2/3, to make that into 6, I had to multiply by 2, right? So I got to multiply the 2 by 2 to get 4. All right, so I have 4/6 and 1/6. Add those guys together, I have 2 to the 5/6. All right, and it says most of the time when we do this, we don't like to leave it as a rational exponent like that. So we like to move it back. This is my exponent form. We like to move it into radical form. All right, so here this is going to be the 6th root of 2 to the 5th power here. All right, so that's the most simplified answer there. You like to write it as a radical if it's an exponent that is a fraction. All right, so now the next one, number 2 here, I have 3 to the 5 halves and then 2 to the 2nd power. And remember, this is a power to a power where we multiply these guys. So this is going to be 3 to the 5 halves times 2. All right, and I know if I'm multiplying fractions, I can multiply just straight across. So this is going to be 3 to the 10 over 2, which 10 over 2 just simplifies to 3 to the 5. All right, so if it's a whole exponent, you can just leave it as 3 to the 5th. You could put that into your calculator and find out what 3 to the 5th power is, but not for our sake right now. 3 to the 5th is fine. All right. Number 3, we have x to the 3 halves over x to the 1/4. So notice I have an x and I have an x. So I can take these exponents here and I can subtract them together because this is the powers of quotients here. Quotient power, we can take them and subtract them. All right. So here Good. I'm going to take these guys and subtract them. So I have x to the 3 halves minus 1/4. All right, so notice again here with these fractions, you got to have common denominators. So do we have common denominators? No, one's a 2, one's a 4. We got to make common denominators. So I have x to the something over 4 minus 1/4, because that's already got the fourth. So now 3 halves, I multiply the 2 by 2 to get 4. So I multiply by 2, and then I multiply the 3 by 2 to get 6. So this guy is going to be x to the 6 minus 1 is 5/4. To make this into that radical, just like I did up here, I have to move that guy 4th root of x to the 5th power here for my answer. All right, good. So you take those exponents and subtract them if it is on from there. All right, so perfect here. We have to look. This next one, I can bring these guys together. So this product up here tells me I can bring them together. So I have, since I have both cube roots here, I can make this into the cube root of 64. All right, and I look over on my sheet and I say, hey, I know what the cube root of 64 is. I know that the cube root of 64 is just 4. All right, so that is my answer there. Simple as that. All right, number 5, I have the 4th root of 625 over 16 here. This guy, I can take the 4th root of 625 and divide that by the 4th root of 16. All right, and I notice here that both these are perfect fourths. So I can just leave this, or I can find out what they are. They're both perfect fourths. This is 5/2, and they're both plus or the minus, so you can put plus or minus on there. Because the 4th root of 625 is 5, and the 4th root of 16 is 2. All right, number 6 is kind of the long one here. So really, you have to take these guys, and since I have a on the top and a on the bottom, I can subtract these two, and I can subtract these two here. So let's write that out, and I can notice here that 2/4, that simplifies to 1/2. All right, so I have 1/2, and then I have a to the, I have 3 halves minus 1/2. And then b to the 1/4 minus 3/4. All right, and here notice that you can take this guy. Now I have, if I move to the bottom, I still have 1/2, but then I have a to the 2 halves, and then b to the negative 2/4, excuse me. So the negative 2/4 there. And I can notice here that these guys simplify. So I have 1 a to the 1st, and then b to the negative 1/2 over 2. All right. And b to the negative 1/2, remember that guy's going to go to the bottom because he's got a negative exponent. So I'm going to have 1 a to the 1st over b to the 1/2 is the square root of b. All right, so I can just keep that square root of b on the bottom, and that's fine for right now. All right, so don't forget there, if a fraction, if you have that quotient of powers, you can take those powers and subtract them. These ones are nice because they had common denominators, so we didn't have to get common denominators. And that negative exponent went in the basement there. All right, awesome. So thank you for listening to this video. If you have any questions, please come and find me. I will be around. Thanks.